Hi, are you a software engineer or a developer out there? And I want to share with you three important concepts of what is going to make you an exceptional software engineer in this artificial intelligence era, in this AI era. And before that, I want to give a bit of a background of what these AI tools have been able to do for us as software engineers, and also some of the limitations we've seen that these AI tools have. No doubt, these AI tools have been transforming the way that we work as developers. We've actually used of these AI tools like ChatGPT, writing some of our software applications. We've used ChatGPT, we've used Gemini, Cloud AI, um, GitHub Copilot, and Tab9, and all of these AI tools, they're becoming incredibly powerful because the models used in training them, they have been improved day by day. No doubt that these AI tools have been so much helping us. Firstly, we've identified that these AI tools have been able to suggest and provide us with code snippets that allow us to build out all of the functionality in our application. Another use case is that we've seen that these AI tools have also been able to identify all of the syntax errors in our code, not logical errors, because these AI tools are not fully optimized for identifying logical errors in our code yet. We've also seen that these AI tools have been able to help us to automate all of the repetitive tasks that we work as developers, making our work to be easy. And what they've done for us is to allow us to focus more on the high level thinking. So, folks, in 2025 and beyond, more of the things that we're going to be doing as software engineers will have to do with more of high level thinking. I am going to give a bit around explanation around that. And what we've seen, as beautiful as these AI tools are, they have a lot of limitations as well. And the first one we've seen about the limitations that these AI tools have, where you fit in, is that these AI tools, they are not able to interpret all of the business requirements in our application development and translate them into technical specification. These AI tools can't do that yet. While we write software applications, the first thing that we are always been given is for us to take all business requirements and start translating them into technical specifications. The point is that translating all these business requirements into technical specifications and building out these applications is far beyond the technical knowledge alone. It has to do with we understanding the long-term business goals. It has to do with we understanding the potential trade-offs. And it also has to do with we understanding around all of the nuances around the application we are developing. So these AI tools are not capable yet in doing that. The second thing we've also identified where you also fit in is that these AI tools are not able to design system architectures that perfectly meet all of our business goals. They are not able yet. These AI tools could actually propose an architectural pattern for us. Say these AI tools, based on the requirements that we send to them, we give them, they could actually let us to know that we could use a microservice architecture or a monolithic architecture or a serverless architecture or an event-driven architecture. But designing a system architecture for our application is far beyond technical knowledge. It has to do with we balancing the present need that we have with the future scalability, with performance, with security, and even with compliance in mind. These AI tools are not able to do that yet. And that is primarily where your strength lies as a developer. Another limitations we find out that these AI tools, they are not able to identify all of the systemic bottlenecks and the potential failures in our application. Because of course, identifying all these bottlenecks and the systemic failures that's going to come up in our application, it has to do, it is embedded in the reuse case of the application. And we've also seen that these AI tools, as powerful as they are, another limitation is that these AI tools, they are not able to make informed decision about the technology choices that we are making for our application development and all of our implementation strategy. They can't make choices for the application, for the technologies we can use. Of course, they could make general recommendation for us, like they could let us to know about the frameworks that we can use. They could let us to know about the programming language that we can use, the libraries that we can use. But these all suggestions are based on the popularity of the technology stacks and the compatibility with these stacks. But making a decision about the technology choice that we're choosing for application development is far beyond technical spec. It has to do with we understanding the business timeline that we have for that project. It also has to do with we understanding the budget that the company is having for the development of that application. And most importantly, it has to do with we understanding, we having to know the team expertise, the strength of the team. You know, the point is that when a company or organization or a startup just raise some fund and they're looking for a software engineer or a developer, what do they mean by that? What they are saying is that, hey, developers, we have a problem. We have a business problem. We believe only technology can solve this problem. We want you to come on board to take all of the business requirements that we have, interpret it in the box of code that you use, what we call your integrated development environment or your code editor. They want you to take this business requirements, interpret it in the box of code that you use, and translate it into an actual software application that their end users can use. That is what these startups, these organizations want from you. But the point is, in this AI era, they are not just looking for a software engineer who could use these AI tools alone to write a bug-free code, which is practically impossible. They are not just looking for someone who is going to make a head to the head count as part of their engineering team. They are counting on you. They want you to come on board as a talented engineer to take all of these business logic, the business logic they have, which is also the business requirement, the business logic has to do with all of the business processes, the set of rules that guide all of the business operation. That is what they want. They want you to take all of this business logic and build them out into an actual software program that their end users can use. And while beyond, in 2025 and beyond, more of the things you're going to be doing as software engineer, not really going to be more around coding, but more around having to understand around these business processes, business logic, translating all these business logics. I've been privileged to lead engineering team at scale, and I've also worked as a software engineer. I want to share with you about three concepts, three things that I have seen that will make you an exceptional software engineer in this AI era, even as you work as software engineer. So I want to share with you three important concepts. What I know it will make you an exceptional software engineer in this artificial intelligence era. So the first one that I want to talk about is your engineering approach to solving technical problem. This is very important. The second one is the depth of your technical communication. And the third is going to be understanding how things work. These three concepts they are very powerful, and I'm going to be talking about them. So the first one is your engineering approach to solving technical problem. Look, every time you want to solve a problem, we talk about that whenever you working an engineer, you're always being presented with a problem. And the problem is every of the UI fixes you're doing, every optimization you're doing, every the bug fixes you're doing, every of all those fixes, those are our problems. And in this time around that you're using most of these AI tools, of course, they could actually write the code for you. But what kind of an approach are you now going to have in your engineering? That's the approach you want to have in solving some of the technical problems that you come across in your day-to-day as you use these AI tools. So the first one is you need to have a deeper understanding about the problem that you are solving. This is very important. As a software engineer, you need to know what kind of a problem that this company or organization is trying to solve. Who are the stakeholders in this application that this startup wants to solve? It's a more around understanding, having a deeper understanding about what kind of the, the problems that these companies are addressing. This is going to be one of the things you need to put in mind, because the point is, while you're prompting these AI tools to solve your problem for you, to write your code for you, the responsibility is on you for you to have a deeper understanding about the problem you are solving. The second one around your engineering approach to solving technical problem has to do with you understanding, having a domain knowledge about the company that you are working for. This is very important. No, say like you're joining a financial company or an education technology company or a logistic company. You need to have a domain knowledge about that. You need to know, because there are peculiarities of the kind of feature that is common to these companies. You need to know what kind of feature that is common to developing application in this field. How about security? You need to know what kind of security that you need to put into consideration while you are writing all of the functionality. You also need to know what kind of an architecture pattern that is common to this industry. These are all about the domain knowledge, because the domain knowledge allow you to understand the features that are common to this industry. It allows you to understand the architecture pattern that is common to this industry. It allows you to understand the kind of trade-offs, what kind of trade-offs that are common to this industry. What are the priorities? What are the part of the features in this sector or in this industry? What kind of priorities that you need to put into consideration? So that's one of the things you need to know while you start writing software program with these AI tools. You need a deeper understanding about the project itself and a domain knowledge about the industry we're writing this software for. The second thing too you need to also put in mind in your engineering approach to solving technical problem has to do with you identifying constraints and the edge cases. Look, there are a lot of edge cases in applications and the constraints when you're writing. A constraints could be what are some of the regulations that governs this industry that you're writing software for. How about compliance? These are all important factors you need to put into consideration. And also, the edge cases are the questions you ask. They are the what if questions you ask. Say you are writing a software program for a financial technology company. You need to know what kind of an amount that is allowed for a user to transfer to another person. What is the maximum amount that is required? How about the rate limit, the API call rate limit? You don't build an application and people start consuming API, making too many API calls. At what point do you know you need to have a limit around it? That's also very important. And in the case of you also doing that, so one of the edge cases I've also seen, say you are writing a software program for a financial technology company, what if you are implementing something that has to do with a third party payment gateway? What if the services of the third party company, what if their services is down? These are all edge cases you need to put into consideration. And then you need to write, while you're writing software application programs or your functionality, your code should be resilient enough to handle all of these partial failures or these constraints or these edge cases. Because if you don't do that, you start finding that when someone is trying to make a transaction and the internet of that person, of the user, get cut off, it could actually be charged 2 times or multiple times. Then you now know that you need to implement what they call retries, or you need to implement what they call rollbacks. Those are not part of the things that you plan for, but these are the things you now start need to consider while you are writing your application. These are the edge cases you need to put into consideration. Then the next thing I want to talk about is you decomposing your solution, the application you're building. This is very, very important in your engineering approach to solving technical problem. While you use these AI tools, as they are going to help you in writing some of the code or the functionality you're building out, you should be able to decompose all the application into manageable pieces, put them into the manageable pieces so that you can be able to identify in isolation all of the functionalities that you want to write. This is very important. You need to spend time to decompose or to break down all of the functionalities that you want to write into different manageable pieces. And the next thing I want to talk about in your engineering approach to solving technical problem has to do with you pseudocoding your solution. This is very important. Pseudocoding your solution has to do with you writing your software application in plain English. That means before you write a functionality for a feature you are working on, you need to spend the time to write the step by step of what you want to do in plain English. Look, what is going to help you to do while you pseudocode your solution? Firstly, it's going to allow you to organize your thoughts and be able to even prompt these AI tools, right? Prompt these AI tools to give you the right suggestion. Secondly, it also helps you in ensuring logical correctness in the functionality that you are writing. And the third thing is that it allows you to identify the best optimal solution that you are writing. The point is that for every application that you are writing or every functionality you are writing, there are multiple ways to solve a problem in software engineering. But not all of the not all that are most efficient enough. There is actually the best way that you can write that. So, because the efficiency of the application that you build is determined by 2 factors. Firstly, it's around what we call the time complexity. And the second thing is the space complexity. The time complexity has to do with the time of execution of your function as the input is growing. This is very important in software engineering. And the second one has to do with the space complexity, which it has to do with the memory space usage or consumption that your functionality takes as the input grows as well. These 2 factors, the time complexity and the space complexity, it has serious business implications, very serious business implications. And that is why, as an engineer, you see, I'm not a fan of LeetCode or HackerRank and all some things like that. But that's the reason why they are pointing you to learn about algorithm and data structure and all that. What they are pointing out there is that when you write your software program, if you are unable to pseudocode, if you are unable to write step by step of how you intend to build this application, you may not be able to identify the best optimal solution that you are writing for. And that is why you need to put that into consideration, the type complexity and as well as the space complexity. Because the point is that you are going to deploy your application on cloud environments like your AWS, GCP, Azure, DigitalOcean, Heroku, and all that. These guys are going to bill you or your organization based on resource consumption. And it has a serious business implication if you build a functionality out that is not well optimized. That's the reason why you need to pseudocode your solution to have, that logical correctness in writing your functionality. And when you are able to do that, you find out that you are reducing infrastructure costs for your company or your organization. And secondly, too, you see that when you build your functionality out there, you are also allowing users to have the best user experience, because the point is that if a user spend more than 3 seconds or 4 seconds of load time in using an application, say they want to log in and spending too much time, it becomes that system doesn't solve the problem it's supposed to solve. Yet you wrote the application well. That's the reason why you need to put that into consideration while you're writing your software application, to ensure that you have the best user experience. At the same time, you are also reducing infrastructure cost for your organization. So you need to pseudocode your solution such that these AI tools can be able to allow you to help you in writing most of these functionality out. And then the other thing I want to talk about is your pattern recognition. Look, the point is that you don't need to reinvent the wheel while you're writing a software program. There are patterns of this application that is already existing that you can take a cue of. While you want to write a software program, there's actually a version of it, a closer version of it, sitting somewhere in a repository or in a public repository somewhere. So it is the responsibility is on you for you to find patterns, identify patterns of the application you are writing with the one that is already existing. You don't need to reinvent the wheel. Look, time is one of the biggest assets you are going to have as a software engineer, and you don't want your companies don't want to waste too much of the time going into the market. So writing your functionalities out, you need to know how to recognize patterns in the code that you want to write. It could be even the existing code base that you're writing features or functionality for. If those features are already existing, you can make use of the modules, the functions that are existing. You can make use of that again. So pattern recognition is also very important in the course of your engineering approach to solving technical problem. And if you're doing this, if you put this into consideration while firstly having a deeper understanding about the problem that you're solving, having a domain knowledge about the industry you're writing the software for, and also identifying constraints and all of the edge cases that you are writing, that in the application you are writing, I also put into consideration the need for you to decompose your solution into manageable pieces, and you also put into consideration the need for you to pseudocode your solution. Write down the step-by-step of how you intend to write the application. If you're putting all of this into consideration, you will find out by default that you are obeying all of the software engineering principles without you knowing. One of the principles is the dry principle. And you find that when you try to decompose your solutions, you find out that you are able to write your software application in such a way that you don't repeat yourself in the code. Don't repeat yourself in the code. You see, you find out that your code is the stuff you write are not repeat. Most of the code are not repeated. And the second one is about the principle of separation of concern. You will be able to write all of the functionalities and the modules that you're writing. You'll find out that you are able to separate all the logic that has to do for the back end, that will be for the front end as well. You find out that you are obeying that principle of separation of concern. And also, the last, which is the single responsibility principle, you will find out that when you are able to pseudocode your solution, you will find out that you are able to obey the principle of that single responsibility principles that allow you to write functionalities. It says that all of the functions that you write, the modules that you write, must do one thing at a time. And you're able to see how these all principles in software engineering is put into place when you consider, when you're able to follow through these processes of your engineering approach to solving technical problems. So, one of the other concepts that I want to share with you that will make you an exceptional software engineer in this AI, in this artificial intelligence era, is your depth of technical communication. This is very, very important, guys, because as you work as software engineers, you find out that these AI tools are helping you to generate code snippet. But that is not where you don't need to stop there. You need to go further, prompting these AI tools to also explain to you a depth around what the functionality has written for you, what it's doing. Because the point is that engineering is collaborative. What I mean is that you're likely not going to be working as a solo developer, someone who is just working on your own. You are going to work with other software engineers. And this is the time when you need to sharpen your depth of your technical communication in explaining hard concepts and some of the complex concept of how your code is working. You're going to be interacting, communicating with the client, with the product manager, with the designers on your implementation strategy. And this is very important. Whenever you write your code, you should be able to explain to these stakeholders on how your code is working under the wood. You're also going to spend time, conversing, having a communication with your engineering lead or your engineering manager or your technical lead about the reason behind your architectural decision. You're going to spend time explaining to your technical lead how the functionality that you wrote is working under the wood. These AI tools could actually help you to generate the code snippet that you used there. But don't stop there. This is what's going to distinguish you from other engineers. You need to spend time understanding how that code is working. You're also going to be spending time talking to your fellow developers, explaining the complex code of your implementation of how the functionality you wrote. You're going to spend time talking to them about how your code is working. You're going to have a peer programming session. You're going to join a code review session. And how about the PRs you make? These things will have to be reviews, and you're going to spend time explaining what exactly is going on in your code. So you're also going to spend time in the documentation, writing documentation about the code that you've written. As good as much as these AI tools can assist you in writing this code, always find time to understand, have a deeper understanding about how the code is working, such that you can be able to explain to your fellow developers or to the next person what is actually happening in your code. And it's also going to be good for you too as a mentor, because you are first a mentor before you become a software engineer. And it's not the other way around. You're going to spend time having to talk to junior developers that are coming up on how the code is working. And by so doing, you find out that in so doing, you are able to learn. You have that ability to learn even more concept of the things you don't know, simply because you're able to explain to others how your code is working. And that is what we call rubber duck debugging in software engineering. It exposes you to some of the concepts that you don't even know before, while you're able to explain it in technical communications, line by line, how the code is working line by line. So this is very important in this space of you using these AI tools. That's it. This is the time you need to start prompting these AI tools also to give you a background knowledge about the functionality they've been able to write for you.